What if everything is built from a secret code? The true count of atoms in one molecule. A code that dictates how the universe cooks. From the birth of stars in the void to the fall of a single drop of rain. This code is called Stoichiometry. The first law: nothing is lost, nothing is gained. Mass is always conserved. Always. So, every chemical equation must balance.
Like a chef's perfect recipe.
But to read the recipe, you need the formula.
For ionic compounds, this is the formula unit. The simplest whole number ratio of its ions. Think of NaCl, common table salt.
But for molecules, it's a different story.
They exist as discrete, bonded units.
This gives us the molecular formula. The true count of atoms in one molecule. What if two things have the same basic recipe, but are completely different substances? This is the power of the empirical formula. So how do we find this hidden formula? 3 magnesiums, 2 nitrides. Neutral. 3 magnesiums, 2 nitrides. Neutral. We perform an experiment. Decomposition. We measure the mass lost. That's the water. Now, we have our first clue, mass percentages. From percentages, we find the mole ratio.
Divide by the smallest number to simplify.
The empirical formula is Qs or Yash 5H Msol.
But what if we need the true molecular formula?
We need one more piece of data. Molar mass.
The final key, N, antis, molar mass / empirical mass. This N is the multiplier. The secret revealed.
Magnesium gives away 2 electrons.
Nitrogen gains 3 to fill its shell.
But their charges don't cancel yet. 2 plus versus a 3.
We need the lowest common multiple, 6.
The Criss-Cross method automates this.
Three magnesiums, 2 nitrides. Neutral. What about aluminum and oxygen? Al-Dri and OOP. This is the logic behind every ionic compound. Now, the ultimate application. Stoichiometry. Using a balanced equation as a map. The coefficients are our conversion ratio. If I have 10 moles of nitrogen,
How many moles of ammonia can I make?
The answer: 20 moles of NH8.
but in the real world, we use grams and kilograms. So we convert moles by grams via molar mass. This is the stoichiometric calculation.
It tells us the theoretical yield.
But reality is mess. What if reactions don't finish?
Or what if we have too much of one ingredient? The limiting reagent decides everything. Stoichiometry finds this bottleneck every time.
It is the indispensable tool of modern industry.
From the lab bench to the pharmacy shelf. To launching missions to Mars.
It all returns to the conservation of mass. The unbreakable law. The universal code. This is stoichiometry, the architect of reality.